Hello, I'm Dr. Smith.
Hello, Dr. Smith. I'm Judy.
Today we're going to explore an incredible process that happens inside your body, leukocyte extravasation. It's like a superhero mission taking place right within you. Leukocyte extravasation is a fascinating journey white blood cells take to reach the site of infection or injury. It's a vital part of your body's defense system. Leukocyte extravasation, also known as leukocyte recruitment or diapedesis, is a crucial process in the immune response that allows white blood cells, leukocytes, to exit the bloodstream and migrate to sites of infection or tissue damage. This multi-step process involves a series of coordinated interactions between leukocytes and the endothelial cells that line the blood vessels. Imagine your bloodstream as a bustling highway, carrying essential nutrients and oxygen. But what happens when there's trouble ahead? When there is an infection or tissue damage occurs, phagocytes like neutrophils and macrophages detect signals from the site of infection or tissue damage. These signals include various molecules released by damaged cells. Upon detecting these signals, phagocytes become activate and engage in phagocytosis. They engulf and digest pathogens, damaged cells, or other debris. At the same time, they also release some inflammatory mediators. These inflammatory mediators such as chemokines, which are the molecules that stimulate and initiate leukocyte extravasation. Let's break down this journey into 4 steps: rolling adhesion, tight adhesion, diapedesis, and chemotaxis. These steps ensure that our immune cells reach their destination effectively. First, there's rolling adhesion, where white blood cells gently roll along the blood vessel walls, scanning for signs of distress. The process begins with leukocytes rolling along the endothelial surface of blood vessels. This is facilitated by weak interactions between selectins, which are adhesion molecules on endothelial cells, and their counter receptors on leukocytes. This rolling motion slows down leukocytes as they move along the vessel wall. Judy, imagine your bloodstream as this dynamic highway. During rolling adhesion, the white blood cells slow down, preparing for the next phase.
So, it's like they're patrolling the area, ready to respond?
Exactly. They patrol the area with the help of a miraculous molecule known as chemokines. Chemokines is an example of cytokines, which are released at the site of infection or inflammation. The chemokines act as signaling proteins that bind to specific receptors on the surface of leukocytes, activating them and promoting stronger interactions with endothelial cells. Now, during tight adhesion, the white blood cells firmly attach to the vessel wall, like a temporary docking station. As leukocytes become activated, they undergo a conformational change in integrins, cell adhesion molecules, on their surface. This change allows integrins to bind tightly to their ligands on the endothelial cells. The primary interaction involves integrins such as alpha-1, lymphocyte function-associated antigen 1, on leukocytes binding to IMMUNOTECHNOLOGY, intercellular adhesion molecule 1, on endothelial cells.
So, they're getting ready to leave the highway and enter the tissue.
You got it. That brings us to diapedesis, the 3rd step, where the white blood cells skillfully squeeze through the vessel wall. Once firmly adhered, leukocytes undergo diapedesis, a process where they migrate through the endothelial layer to reach the tissue. This can occur between endothelial cells, paracellular route, or through them, transcellular route. Leukocytes move between adjacent endothelial cells by actively pushing and squeezing through the endothelial cell junctions. This process involves interactions with junctional proteins like PECK1, platelet endothelial cell adhesion molecule 1, and CD99. Leukocyte migrates through the body of an endothelial cell. This process involves the formation of a temporary pore or tunnel through the endothelial cell, allowing the leukocyte to pass through.
Sounds like a tight fit. How do they know where to go?
That's where chemotaxis comes in. The white blood cells follow chemical signals, like a trail leading them to the source of trouble, such as an infection or injury. After passing through the endothelial layer, leukocytes need to traverse the basement membrane and any underlying tissue to reach the site of infection or injury. Chemotaxis allow the directed movement of leukocytes along the chemokine gradient. In chemotaxis, chemokines are secreted by the cells at the site of infection, injury, or inflammation. These chemokines create concentration gradients, chemotactic gradient, with higher levels of chemokines near the source of inflammatory stimulus, thus guide them towards the site of inflammation. Chemokines bind to their chemokine receptors on the leukocyte cell surface when the leukocyte encounters the chemokine gradient. This binding activates the leukocyte and trigger a series of intercellular signaling events that lead to changes in the leukocyte cytoskeleton, allowing it to move in the direction of chemokine gradient.
It's like they have a GPS guiding them to the problem.
Exactly. Your body is an amazing and well-coordinated system.
You're right.
And there you have it, the journey of leukocyte extravasation, a testament to the incredible ways your body works to keep you healthy. Next time you feel a bit under the weather, remember the superheroes inside you, your white blood cells.
That's pretty amazing. Thanks, Dr. Smith, for helping me understand how my body fights off invaders.
You're welcome. Your body is a marvel, and it's always working to keep you well. Take care.
Thank you, Dr. Mahfuz.